Today, I, Aditya Dua, will be delivering an intriguing blend of traditional and modern technologies. Let's explore how we can use the Arduino Nano 33 IoT board to bring Morse code and the world of Internet of Things together. The components required for the working of this application are Arduino Nano 33 IoT, push button, micro USB to USB A cable, Wi-Fi enabled device, which can be laptop or a smartphone, and an Arduino IDE software. So let's start with what is Morse code. Morse code is a text encoding system that uses a series of two symbols, dots and dashes. A distinct sequence of these symbols represents each letter, number or special character. Morse code is distinguished by its efficiency with more common symbols represented by shorter codes to improve communication speed. Here is a circuit diagram for the required application. Code breakdown. Now let's take a look at the heart of our project, the Arduino code. This code will control the blinking of the LED in Morse code patterns. It's important to understand its key components and logic to show how the LED transforms into a communicator. Starting with initialization and pin configuration. At the beginning of the code, we define constants for the LED pin and the button pin. These constants hold the respective pin numbers. Additionally, we set the durations for a dot and a dash in milliseconds. A dash is 3 times longer than a dot, adhering to Morse code conventions. We also create a 2D character array to store Morse code representations of letters. This array serves as a lookup table for converting characters to their corresponding Morse code sequences. Tracking progress, blinking state and initializing pins. The variable current letter keeps track of the current letter being blinked in the Morse code. It is initialized to 0. The Boolean variable blinking indicates whether the LED is currently blinking. It's initially set to false. The setup function is executed once at the start. It configures the pin's mode. The LED pin is set as an output pin to control the LED, and button pin is set as an input pin with pull-up resistor activation for the button. Button press check. The loop function is the main program loop that runs indefinitely. It checks whether the button connected to button pin is pressed. If the button is pressed, it proceeds to the next step. If the blinking state is false, it switches blinking to true and starts the blink name function. If blinking is already true, it turns off the LED and sets blinking to false. A debounce delay of 300 milliseconds prevents rapid toggling. The blink name function is responsible for blinking the Morse code representation of a name. It operates as long as blinking is true. Blinking individual letters. Inside blink name, the program retrieves the Morse code sequence of the current letter using the current letter index. If the letter is /0, end of Morse code for the current letter, it resets current letter to 0 and introduces a 1-second pause to mark the end of a name repetition. If the current letter is not at its end, the code iterates through the Morse code sequence for the letter. It blinks the LED to represent dots and dashes as specified in the Morse code. For each encountered, the LED is turned on for dot duration milliseconds. For each dash, the LED stays on for dash duration milliseconds. Creating spaces and separating letters. Between dots and dashes of the same letter, there is a small gap represented by an LED turned off for dot duration milliseconds. This gap creates visual distinction between elements of the same letter. After blinking a complete letter, there is a longer pause represented by an LED turned off for dash duration milliseconds. This gap separates letter within the same word. Moving to the next letter. After blinking a complete letter and gaps, the current letter index is incremented to move on to the next letter's Morse code sequence. The function then loops back to continue blinking the next letter or handling repetitions depending on the blinking state. That was all for the first name blinking on an Arduino Nano 33 IoT by the use of Morse code. Thank you.